Hello, this is Mrs. Grisafi, and we are on 4.01 geometry notes today. And we're going to be talking about, we're starting a new unit on triangle proofs. And we're going to be focused today on just side, 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 and side angle side proofs, triangle proofs. All right, so the first thing is, normally when you prove two triangles or two figures congruent, you have to get all the sides and all of the angles congruent. These are some shortcuts that will allow us to just get three sides congruent to another three sides, or two sides and an included angle. So if you had two triangles, A, B, C, and D, E, F, and I knew that segment AB was congruent to segment DE, segment BC is congruent to segment EF, and segment AC is congruent to segment DF, then I would know that two triangles are congruent by side, side, side. When you write your congruency statement, it's really important that you match up your corresponding parts. So A is between the 1 mark and the 3 marks. I'm going to call it ABC first. So that means whatever matches up with A has to be between the 1 and the 3 marks. So here's a 1 mark and a 3 mark on the other triangle, so that means D corresponds to A. B is between the 1 mark and the 2, so E is also between the 1 mark and the 2, so that'll go next. And then C is between 2 marks and 3 marks, and that corresponds to F. And those would be congruent by side, 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 because all three pairs of sides are congruent. The other one we're going to talk about today, I'll draw these same pictures again. So triangle ABC and triangle DEF, is if I had a pair of sides congruent, a pair of corresponding angles congruent, and then another pair of sides congruent. But what's really important is that the angle is included between the two sides for this one. So we would say same triangle, so they're going to match up the same way as I just did it in the first one. But this one would be by side angle side, or SAS. And again, really important that the A is between the two included sides. If you don't know what that means, try tracing the two sides that you got congruent in one triangle. So this and this. Whatever angle they form that you just traced, that should be the angle that's congruent in the other triangle. Okay, so very important that that angle is in between the two sides. All right, so those are the two that we're going to be talking about today. And I just want to review, kind of go over how to write these congruency statements and finding our corresponding parts. So list the congruent corresponding parts for triangle ABC, which will be congruent to triangle QTJ. So here's our picture. This is A, B, C. Again, obviously not drawn to scale. All right, so to match these up, you really want to use this congruency statement. Congruence statement. Very, very important. So A is the first letter and Q is the first letter. So angle A should correspond to angle Q. So notice my picture doesn't look, they don't match up maybe how you might think they do. So it's most important to be using this congruency statement right here to match up your corresponding parts. So angle A is congruent to angle Q. Angle B, so the second letter, is congruent to angle T. So I'm going to use 2 marks to mark them. And then lastly, angle C is congruent to angle J. So we'll use 3 marks there. And now for the sides, do the same thing. So side AB, which is our first 2 letters, should be congruent to side segment QT. Notice they're between the 1 mark and the 2 marks on the angles. So segment AB congruent to segment QT. Segment BC is congruent to segment TJ, because those are the last 2 letters. And then the first and the last letter, segment AC, should be congruent to segment QJ. C and QJ. And those are your corresponding parts. So you could have done that straight from giving this without being given the picture. The picture actually made it more confusing. So make sure you're really careful and you're focused on your congruency statement as opposed to the picture, because sometimes that makes it a little bit harder. All right, next up. Just kind of writing out your congruency statements and figuring out how you can get the triangles congruent. So write a congruency statement and state why the triangles are congruent. And if you can't get them congruent, you can state that as well. So the first one, let's do something like this. Again, not drawn to scale. I'm not using a ruler here, just kind of sketching for you guys to get an idea. All right, so in this case, we want to see if the triangles are congruent to each other. So I might give you that those two are congruent and those two segments are congruent. So from looking at this picture, you should be able to tell that vertical angles are congruent. Let me change to a different colored pen so you can see the difference between what's given and what I'm adding. So black would be all given. So I'm adding that the vertical angles are congruent. I don't know if you can see the difference on there. Here, pink, hopefully you can see that. So those vertical angles are congruent. So now I have a side, an angle included between the two sides, and the other side. So that tells me I can get these two triangles congruent by side, angle, side. And then I need my congruency statement. The triangle what congruent to triangle what. So let's call this one CBA. So to figure that out, C is between no marks and 2 marks. So on the other triangle, I want to find no marks and 2 marks. Here's no marks, here's 2 marks. That makes B. B is at the middle between 2 and 1. So B is also in the middle here between 2 and 1. And then A is between no marks and 1 mark. D is between no marks and 1 mark. So that would be your congruency statement. Again, so important that you match up your corresponding parts appropriately. Let's see here. We've got A, B, C, D, given those two are congruent and those two are congruent. So now from this one, I don't have any vertical angles I can take from the picture, but I can take that this third side is shared. It's part of the triangle ABC, and it's also part of this bottom triangle. So I can say that segment AC is congruent to itself. That's a reflexive property, so I marked it with an X. Now looking at my picture, do I have side, angle, side, or do I have side, side, side? And it looks like I have all 3 sides. So I know it's going to be side, side, side. I just need my congruency statement. So let's call the first triangle CBA. So C is between no marks and 1 mark, and A is between no marks and 1 mark. So be careful, because you might think that C would correspond to C in the other triangle, and that's not always the case. And then B is between 1 mark and 2 marks. D is between 1 mark and 2 marks in the other triangle, and then your C. Okay, let's do another one here. We have A, B, C, and then I'm going to drop the perpendicular here, D. I'm going to tell you that segment AD is congruent to segment DC. So again, you've got reflexive property right here that the 2 triangles share that side. So it looks like here I could get the triangles congruent by side, angle, side. And then I just need a congruency statement. So let's call this one triangle BDA. So B is between no marks and the X. B in the other triangle is between no marks and the X. D is between the X and the 1. D again is between the X and the 1. And then A is between no marks and 1 mark. C is between no marks and 1 mark. And the last one, use something like this. A, B, C, D, E, F. And I'm going to give you that we have actually, take that back. Do not want a right angle there. I white out here. Okay, so let's say angle B is congruent to angle D. So we do not have a right triangle, even though they appear to look like it. I took off that marking, so we can't assume that they are. And then EF and AC. So here we'd look and we say, okay, we have two sides and an angle marked. So do I have side angle side? So the question is this angle included between the two sides? So again, if you're not sure, trace the sides that you know are congruent. They formed this angle A up here. So do we have angle A congruent to angle F? And the answer is no. We know that angle B is congruent to angle D. So we do not have side angle side. We have something called side angle, which is not allowed. It's just not possible. There's actually two different triangles that you could make. So it's not one of the possibilities to make triangles congruent to each other. So that's all we could do there. All right, next up, we're going to look at some proofs. Okay, so that was 4. We'll make this one number 5. So given that segment AB bisects segment CD and segment CD bisects segment AB, AC equals BD, I want to prove that triangle ACP is congruent to triangle BDP. And here's your picture. So similar to one of the pictures we just drew. Again, not drawn to scale. B and D, we're going to call this angle 1 and angle 2. All right, and then start with our statements. And reasons. First is our givens. Segment AB. I'm going to change up the wording here. Segment AB and segment CD bisect each other. Just to make it a little bit faster. And AC equals BD is also given to me. Now I also want to start by marking my picture. So I've got segment AB bisects segment CD. So a segment bisector goes through the middle of the segment and splits it into two congruent parts. Segment CD bisects segment AB, so that splits that into two congruent parts. And then we're given that AC is equal to BD. So notice I marked it, each one with a different amount of tick marks, because we know they're not congruent to each other. All right, so we want to get the two triangles congruent. If it helps, you can trace them in two different colors. This one you have 3 sides, it looks, that are congruent. So my goal here might be to use side, side, side. But I also could use my vertical angles here if I wanted to. And in that case, I would be able to use side angle side. So you really can use whichever method you'd like for this one. And that's the great thing about proofs, is a lot of times we have other options. All right, so in order to get triangles congruent, you have to have those 3 pairs of parts congruent. Right now, I don't have any of those, so I need to conclude from my given. So what can I conclude from segment AB bisecting segment CD? Well, I can say when AB bisects segment CD, that segment DP is congruent to segment PC. The same reason is why segment CD bisects segment AB gives me that segment AP is congruent to segment PB. And the reason is just definition of a segment bisector. So segment bisector splits a segment at its midpoint into two congruent parts. So what I like you to do is, as you go through, label what you have. So now I just got a pair of sides congruent, another pair of sides congruent. So I'm doing side, side, side. I have 2 out of the 3. So now I need to get my third pair of sides to be congruent to each other. We were given that AC equals BD right here. So we can switch that to congruency, because in order to have congruent triangles, you need 3 pairs of congruent parts, not equal parts. So I'm going to switch segment AC congruent to segment BD. So all I did from here to here was I switched it from equality to congruency. As soon as I use congruency, I should have the segment bars over the tops. And the reason for that is just def of congruency, or you could say segments that have equal length are congruent. And that gives me my third side. Now, if you wanted to do it using side, angle, side, so this would be an optional step, you would say in here angle 1 is congruent to angle 2, because vertical angles are congruent. So that would give you the A. So then you'd have your 2 sides and your angle. So you want to make sure you have all of these checked off first before you get the triangles congruent. Once you have those 3 pieces checked off, now you can say triangle ACP is congruent to triangle BDP. And we only get triangles congruent, never equal. So here, again, you would use whichever method you use. So I would have used side, 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 and then I wouldn't have needed this piece. If you did the vertical angles, then you could do side, angle, side, depending on how you chose to do that proof. Okay, let's do number 6. So for number 6, we're given CE equals DF, angle 1 is congruent to angle 2, AE equals BF, and I want to prove that triangle AFD is congruent to triangle BEC. And then my picture over here goes, it doesn't go all the way to the corner over there. Same here. Those should be straight lines. A, F, B, C, and D. All right, so let's start with our 2 columns. First step is always our given. And then, of course, we need to mark our picture. All right, so I have CE, this whole segment here. So I kind of mark that with this, is equal to DF, and angle, I'm going to call this 1 and 2. Angle 1 is congruent to angle 2. And then AE, so I already used 1 mark, so now I'm going to use 2 marks, equals BF. So since these are overlapping, sometimes it helps to trace them in 2 colors. So A, F, D, and I'll use green. Hopefully you can see that on there. So we want to get the pink and the green triangles congruent. So the pink is on the left, the green is on the right. So to do that, we need to use one of our methods. So at this point, we only know 2 methods, side, 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 or side, angle, side. So let's look at what we have. We know this full side in the green is congruent to this full side in the pink, so that gives me a side. And then I have an angle in each of them. So if you look at this green triangle, this angle down here. Another thing that often helps when the triangles are overlapping is to draw them kind of outside of the picture. So make sure you label CBE, and then you can mark off that's angle 2, and we know that's congruent. And then the pink one is DAF, and we'd have that segment congruent, and this is angle 1 congruent. Okay, so far it looks like we have a side in each and we have an angle in each of them. But we know we need 3 different parts to be congruent. So first I might say, okay, well, first of all, I only have CE equal to DF. I need congruent parts to make congruent triangles. So I'm going to take segment CE congruent to segment DF. And I just changed that from equals to congruency, so by def of congruence. Okay, so that gives me a pair of sides, and here I have a pair of angles. So how am I going to get my third piece? Well, look at what our other given that we haven't used yet. AE equals BF. So AE is not a full side of pink triangle. The pink triangle has 3 sides, 1, 2, 3. This is part of one of the third sides. We need the full side to be congruent. So how could I get that full side congruent to BE? So my goal here is to get segment AF congruent to segment BE. So to do that, I need to look and say, okay, well, AF is made up of AE and EF. BE is made up of BF and FE. They're both made up of EF. So by reflexive property, I know EF is equal to itself. Now I can use segment addition because I have 2 sets of equals. I know the 2 parts are equal to the 2 parts of the green segment. So that's going to bring us back to the proofs we started with our 3-step process. So we need to have 2 sets of equals. So far I have a CE equals DF, or sorry, I have AE equals BF. Now I need EF equals EF. So those are my 2 sets of equals. And that's equal to itself by the reflexive property. Okay, so now I have 2 sets of equals, so I can take AE plus EF equals BF plus EF. So if I add equals to equals, I get equals. So addition property of equality. Now I need to get AF on the board. My goal is to get segment AF congruent to segment BE. So if I can get them equal first, then I can easily switch them to congruency. So I'm going to take AE plus EF and set that equal to the whole segment, which would be AF. And then I'm going to take BF plus EF, and that'll equal those 2 parts would add to the whole of BE. And that is your segment addition postulate, which just means the sum of the parts equals your whole. So our goal again is to get AF congruent to segment BE. So I say, okay, well now I know AE plus EF is equal to BF plus EF. So if those 2 are equal, then I know AF is equal to that, and BE is equal to that. So I can substitute them in. So AF equals BE by substitution. And again, we need congruent parts to make 2 triangles congruent. So I need to switch those to congruency by def of congruence. Now I have my sides, my third pair of congruent pieces. So that's going to give me AF congruent to BE. So now I have side, angle, side, and the angle is included between the 2 sides. And in my proof, I have SAS all written out there. So I've gotten my S, my A, my S. Once I have all three congruent statement, not equality, but congruency, now I can say that triangle AFD is congruent to triangle BEC, and that is by side, angle, side. Sorry, excuse my reach. I need to grab my next piece of paper. All right. Next, last one for today. Given that segment AC and segment DF bisect each other at E. And segment AD is congruent to segment CF, and I'm going to give you a picture in just a moment, and prove that triangle DEA is congruent to triangle FEC. Okay, so a little more complicated picture on this one. So we've got a big triangle right here, and then this one comes off to here. Okay, so that's D, E, again, not trying to scale, B, A, statements and reasons. And again, with this proof, you're going to have more than one option of how you want to do it. First, we're always going to start with our givens, though. Segment AC and segment DF bisect each other at E. Segment AD is congruent to segment CF. Let's mark our picture. So I've got AD congruent to segment CF, and AC and DF bisect each other at E. So they both bisect each other. Now I want to get triangle DEA over here in pink congruent to triangle FEC in green. Well, it looks like just from marking my givens, I already have that. I have side, side, side for both of them. If you also looked at it and you thought, oh, well, we've got vertical angles because you've got your X right here, you also could have done side angle side. Okay, but I'm going to do it using side, side, side here, just a little bit faster. So first I need to conclude from my givens. So important. If you don't know how to do a proof, you need to at least conclude from your givens, which will give you some points right off the bat. So what can I conclude from these two bisecting each other? Well, I know then that segment DE is congruent to segment EF, and I know that segment AE is congruent to segment EC, and that is by definition of a segment bisector. If you are struggling with proofs, again, I strongly recommend that you need to go to that packet of material I posted for the proofs, and you need to learn, memorize, study your boxes. So look at the givens, fold the paper back if you printed it out, or cover it up somehow, and then test yourself. You should be able to give the two columns after the first one, so the conclusion and the reason. All right, so far now that gives me two pairs of sides. I need a third pair. So it looks here I have segment AD is congruent to segment CF. That gives me my third pair of sides. So a nice short proof here. Now that I have my three pairs of sides, I can say triangle DEA is congruent to triangle FEC by side, side, side. If you had wanted to do side angle side before the step 3, you would have said angle CEF is congruent to angle DEA, and that's because vertical angles are congruent. You also could have put numbers inside here if you want, called angle 1 congruent to angle 2. You could not have called them both angle E, though. You have to give it 3 letters for each angle, or the number would have been fine. All right, and that is it for our side, 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 and side angle side proofs today. Hopefully those make sense, but if you do have any questions, please be sure to let me know. I hope you have a great day, and I hope to see you all soon. Pie out.